In this video, we are going to solve some problems on electric field. So we have got the first problem: electric field lines in the region surrounding charged particles 1, 2 and 3 are shown in the figure. If sphere 1 is negatively charged, so they have told us that sphere 1 is negatively charged, and it's also labeled here if you look at the diagram. Then it's asking you what's the charge on 2 and 3. So now we will look at the electric field lines. They have not given us any arrows on the electric field lines, but we know that this is negatively charged, and the lines are connecting between 1 and 3. You can see that 1 and 3, there are lines which are connected between them, and between 1 and 2 also it's connected. But between 2 and 3, there are no lines which are connected or which are moving from 2 to 3 or 3 to 2. So that tells us that 3 must be a positively charged particle, because electric field lines start from positive and enter into negative. So that's why you can see that the lines are connected between 3 and 1. And 2 is also positively charged, because again we can see from 2 some of the lines are going into 1. That means the lines from 2 are moving towards 1. So lines start from 2 and enter into 1. Between 2 and 3, you can see that the lines are not connected because they are positively charged. That means there is repulsion between them. Next problem. Points A and B are distances D and 2D from the charge plus Q as shown. At point A, from a charge, the magnitude of electric field is E. What would be the magnitude of electric field at point B from the same charge? So we have got at point A, that means at this point electric field is E when the distance is D. When you increase the distance, when you double the distance, what will be the new electric field? That's what the question is asking. So if we recall, electric field for a point charge has the formula K Q over R square. Now here the distance is represented by D. The D is becoming 2D, that means it's doubled. That means it's the same as saying that R is becoming 2R. So in the formula we can write KQ instead of R. I will write 2R because the distance is doubled, and then put a square. So that's our new electric field. So let's open the bracket. KQ over 2 square will give you 4, and R also has a square, so we'll keep it as it is, R square. So we can see that KQ over R square, that's the original electric field, and we have got an extra number here, 4 in the denominator. That means the new electric field is E, which is the original electric field, over 4. So our new electric field has decreased and has become 1/4 of the original electric field, which is part A. Okay, let's look at this problem with some numbers here. Two identical point charges, each with a charge of plus 10 microcoulomb, are located along the x-axis at x equal to negative 2 centimeter and x equal to 4 centimeter as shown below. So we have got two charges, 10 microcoulomb at negative 2 and positive 10 microcoulomb at 4. What is the magnitude of net electric field at origin? So that's our point where we want to focus. So let's just highlight it. So this is the point, this is the origin, and we want to find the electric field at origin. Now you need to remember that electric field is a vector quantity, it has direction, and the formula for point charge is KQ over R square. So it has direction and magnitude. Magnitude you can find with the help of the formula, but for direction we have to check, is it a positive charge or is it a negative charge. So let's look at Q1 first. So Q1 is a positively charged object, or it's a positive point charge, and from positive charge the electric field lines go outwards. So if I want to draw the electric field line at origin, because of Q1, it will point to the right. So that I will label as E1, and I am drawing that in red color. So the red color E1 and the arrow which is to the right is for Q1, which is a positively charged point charge, positively charged object. Now the second one, Q2, that's also positively charged object or a point charge, and for positive we know that the electric field line should point outwards. So here at point 0, that is at the origin, if I want to draw it, it would look like this. So let me just draw it with a blue color. That's E2. So we can see that E2 is pointing to the left and E1 is pointing to the right. So again, how did I draw the electric field vectors? By looking at the charges. Both the charges are positive, so the electric field for both of them should be away from them. So for a positive charge, if you remember, for a positive charge, electric field lines point outwards or away from the charge. Now we want to find net electric field. So first we will find what is E1. E1 will be K Q1 over R1 square. K is 9 times 10 to the power of 9. Q1 is 10 microcoulomb, so I'll write 10 times 10 to the power of negative 6 over R1. Now what's the distance between Q1 and the origin where we want to find the electric field? We can see that its coordinate is negative 2, so it has a distance of 2, and the unit you can see it's given here, it's 2 centimeter, and 2 centimeter will convert to meter. So 2 centimeter, if I want to convert to meter, I'll divide by 100, that will be 0.02 meter. So 0.02, and then there's a square in the formula, so we need to put the square. I'm going to use my calculator. If you are solving with me, you can also use the calculator and double check. So this gives me, just a minute, that's 10 to the power negative 6 over 0.02 square, and this gives me the answer as 225, and then it's followed by 6 zeros. So 1, 2, 3, 4, 5, 6, and I'll put the unit as Newton per coulomb. That's the electric field for Q1. Now if you want, we can write it in the scientific format 1, 2, 3, 4, 5, 6, 7, 8. I can write this as 2.25 times 10 to the power of 8 Newton per coulomb. Now we need to find the next electric field, that is E2. So let's just write it here. E2 is KQ2 over R2 square. So 9 times 10 to the power of 9 times Q2 is 10 times 10 to the power of negative 6 R2. Now what's the distance from the origin till Q2? It has a coordinate of 4. So 1, 2, 3, 4. 4 centimeter will convert it. It will become 0.04 square. Again, I'm going to use the calculator. So 9 times 10 to the power of 9 times 10 times 10 to the power of negative 6 over 0.04 square, and that gives me the answer as 5625, and that is followed by 4 zeros. 1, 2, 3, 4 Newton per coulomb. Okay, so now let's just write the directions also. So E1 was pointing to the right and E2 is pointing to the left. You can see it in the diagram. So we are going to find E net. So that means we need to subtract, because one is pointing to right and one is pointing to left. They are in opposite direction. So we'll subtract, and I'll write E1 minus E2. because E2 is a smaller number. You can see 1, 2, 3, 4, 5, 6, 7, 8, only 8 digits here, and obviously these are more than 8. That means E1 is a bigger number and E2 is a smaller number, and let's just subtract it. So 225 followed by 6 zeros. Okay, let me just do that. That will come out as, answer here will come out as 16875 followed by 4 zeros Newton per Coulomb, and our direction will write as right, to the right. So that's the okay, so here it's just asking for magnitude, so you can stop with the number here. That's our answer with the unit. Let me just highlight it. Okay, and in the second part it's asking you what's the direction. There we can write that it's pointing to the right. The net electric field is towards right. Okay, next it's asking at what location along the x-axis will the electric field be 0. So we want to find on this x-axis, where will the electric field be 0. So E net should be equal to 0. Now because in this problem both the charges are positive, so the point should be somewhere in between, because in between you can see that the electric field are going to be opposite to each other. So if they have to cancel out and become 0, they have to be opposite to each other. So we know that the point should be somewhere in between the charges. Okay. Also they have made it little simpler because they both have the same magnitude. Both of them are 10 each. That means it should be exactly in between the two charges. So if we look at the distance between the two charges, 1, 2, 3, 4, 5, 6, there is a distance of 6 centimeter between the two charges. So exactly in the midpoint, that is 3 centimeter, which will be 1, 2, 3. That means at this point, the electric field, the net electric field will become 0. So that is x equal to, the coordinate is x equal to 1. So when they say at what location will the electric field be 0, we can say that it will be 0 at x equal to 1 centimeter, and you can also give the reason for it, because it will be the midpoint. Both the charges are positive and they have the same magnitude, so it will be exactly in between them, which is x equal to 1 centimeter.